In 1949, a US airman named Earl Dedman mailed 36 kernels of strange grain home to his father's farm in Fort Benton, Montana. Someone had told him the seeds came from an Egyptian tomb. The kernels were enormous, golden amber and curved, twice the size of any wheat his father had ever planted. Within 6 years, those 36 seeds had become 1,500 bushels. The father called it King Tut's wheat and showed it at the local county fair. Then interest faded and the grain nearly disappeared. Over a decade later, a 16-year-old kid named Bob Quinn saw those same kernels in a jar at that county fair and never forgot them. He earned a PhD in plant biochemistry, came back to Montana to farm, tracked down the last remaining seed, and spent years figuring out what it actually was. It was not Egyptian tomb wheat. The grain traced its origins to a region of ancient Persia called Corusan, a province that once stretched across northeastern Iran, Afghanistan, and Central Asia, sitting at the crossroads of the Silk Road. It had never been hybridized with modern varieties, never been put through a breeding program. It was an ancient grain still growing in its original form. This is the story of Corusan wheat. What it was, why it was nutritionally superior to the wheat most of the world eats today, what modern breeding did to the grain that replaced it, and why scientists and farmers are now racing to bring it back. What was Corusan wheat? If you held a kernel of Corusan wheat next to a kernel of the bread wheat in your pantry, you would not believe they were the same kind of plant. Corusan kernels are 2 to 3 times larger, golden amber in colour, elongated, with a glassy, almost translucent quality. 1,000 kernels weigh up to 60 grams. 1,000 kernels of modern bread wheat weigh roughly half that. The grain is named after the historical province of Corusan, a vast region of ancient Persia that stretched across what is now northeastern Iran, parts of Turkmenistan, Afghanistan, and Central Asia. This was Silk Road territory. For centuries, Corusan was one of the wealthiest and most fertile agricultural regions in the world. The medieval Persian geographer Al-Maqdisi, writing in 988 AD, described it as a fertile country producing many kinds of grain and fruit. Corusan wheat was one of them. Botanically, it is a tetraploid wheat, meaning it carries 4 sets of chromosomes instead of the 6 sets found in modern bread wheat. This places it closer to its wild ancestors. In 1921, the English botanist John Percival published a monograph called The Wheat Plant, in which he identified Corusan as one of the oldest cultivated wheat species on Earth, native to the Fertile Crescent, and closely related to emmer and einkorn, the original ancestors of all domesticated wheat. The grain spread along trade routes in every direction, westward through the Mediterranean, where it took root in the dry soils of southern Italy, Greece, and North Africa, eastward into China, along the same caravan routes that carried silk and spices. Archaeobotanical evidence from the medieval site of Tashbulak in the mountains of Uzbekistan, dated between 800 and 1100 AD, documents the kinds of grain moving through Central Asian agriculture during the medieval period. Medieval geographers writing in Arabic documented the farmsteads and cities of the Corusan region in detail. The geographer Al-Maqdisi, completing his survey of the Islamic world around 985 AD, catalogued the agricultural wealth of the region. This was not marginal land. It was the breadbasket of the Eastern Islamic world. Farmers grew Corusan wheat in regions with long dry summers and cold winters, in soils too poor and too dry for other crops. The plant grew tall, sometimes reaching 4 to 5 feet, with deep roots that reached moisture other varieties could not access. It tolerated drought better than durum wheat, the hardiest of its modern cousins. Where shallow-rooted grains withered in a dry season, Corusan held because its root system pulled water from layers of soil that other plants could not reach. Here is what made Corusan different from the wheat that replaced it. It was not bred for speed, uniformity, or maximum yield. It was bred for survival. For thousands of years, farmers selected the seeds that grew tallest, rooted deepest, and produced the most nutritious grain under the worst conditions. That selection pressure created a wheat with a fundamentally different nutritional profile from the one the modern world eats today. What Corusan gave the body. The nutritional gap between Corusan wheat and modern bread wheat is not subtle. Corusan contains up to 40% more protein. It delivers significantly higher levels of selenium, magnesium, zinc, and vitamin E. A 100-gram serving provides 29% of daily protein needs, 46% of daily fiber needs, and 136% of daily manganese. The grain is rich in carotenoids, the antioxidant pigments that give it its deep golden color and that modern white wheat has been stripped of almost entirely. But the numbers on the label are only half the story. The other half is what modern wheat lost. In 2020, a study published in Scientific Reports analysed archived wheat samples spanning 166 years, from the mid-1800s to the present. The researchers found that the concentrations of zinc, iron, copper and magnesium in wheat grain remained stable from 1845 until the mid-1960s. Then they dropped sharply. The decline coincided exactly with the introduction of semi-dwarf, high-yielding wheat varieties. A separate synthesis of 243 field studies published in Nature Food confirmed the pattern on a global scale. In India alone, wheat cultivars released between 1960 and 2010 showed a 30% decline in zinc concentration and a 19% decline in iron. The reason was the Green Revolution. Starting in the 1950s, the American agronomist Norman Borlaug crossed high-yielding wheat lines with a Japanese dwarf variety called Norin 10, producing plants with short, thick stalks that could support heavier grain heads without falling over. By 1963, 95% of Mexico's wheat used these semi-dwarf varieties. Harvests were 6 times larger than they had been 20 years earlier. Borlaug won the Nobel Peace Prize. The world grew more wheat per acre than at any point in human history. But the new wheat needed synthetic nitrogen fertilizer, chemical fungicides, and consistent irrigation. The plants were short, their roots were shallow. They pulled fewer minerals from the soil. The grain they produced was high in starch and low in almost everything else. We bred wheat for yield and accidentally bred out the nutrition. Corusan was never part of that process. It was never crossed with Norin 10, never dwarfed, never optimized for industrial farming. It kept the same genetic architecture it had carried for 5,000 years. The nutrients that disappeared from modern wheat, the zinc, the iron, the selenium, the protein, were still there in Corusan, exactly where ancient farmers had selected for them to be. What science found inside? Beginning in 2011, a team of researchers at the University of Florence in Italy, led by Professor Francesco Sofi, ran a series of clinical trials comparing Corusan wheat directly against modern wheat in human subjects. The results were striking. In the first trial, published in the European Journal of Clinical Nutrition, 22 healthy volunteers spent 8 weeks eating products made entirely from Corusan wheat, followed by a washout period, followed by 8 weeks eating the same products made from modern wheat. After the Corusan phase, their total cholesterol dropped 4%. Their LDL cholesterol, the dangerous kind, dropped nearly 8%. Blood glucose fell. Magnesium levels rose. Markers of oxidative stress, the cellular damage linked to aging and chronic disease, dropped by over 20%. But it was the inflammation markers that caught the researchers' attention. Pro-inflammatory cytokines, The chemical signals the immune system uses to drive inflammation fell dramatically. IL-6 dropped 24%. IL-12 dropped 28%. TNF-alpha, one of the most damaging inflammatory compounds in the human body, dropped 35%. When the same subjects switched to modern wheat, every one of those markers rose back to baseline. The Florence team then tested Corusan on patients with irritable bowel syndrome. 20 participants replaced all wheat products in their diet with Corusan versions for 6 weeks. Abdominal pain decreased, bloating decreased, stool consistency improved, tiredness improved. The circulating levels of pro-inflammatory cytokines fell again, including IL-6, interferon gamma, and vascular endothelial growth factor. When they switched back to modern wheat, the symptoms returned. Further studies from the same team found that Corusan improved risk profiles in patients with acute coronary syndrome and non-alcoholic fatty liver disease. The pattern was consistent across every trial. Modern wheat triggered inflammation. Corusan reduced it. The mechanism lies in the grain's antioxidant profile. Corusan contains significantly higher levels of polyphenols, selenium, and carotenoids than modern wheat. These compounds neutralize reactive oxygen species, the molecules that damage cells and drive chronic inflammation. Selenium alone plays a critical role in thyroid function, immune response, and cellular repair. The Kamut trademark requires every harvest to contain between 400 and 1,000 parts per billion of selenium, a range that reflects how consistently the grain delivers this mineral when grown in the right soil. Modern bread wheat, bred for yield and stripped of its antioxidant pigments during roller milling, provides almost none of this protection. The golden color of Corusan is not cosmetic. It is the visible signature of carotenoids, the same class of compounds found in carrots and sweet potatoes, still present in the grain because no one bred them out. What happened to Corusan? If Corusan was nutritionally superior, tolerated drought, and grew in soils where other wheat failed, why did we stop growing it? The answer is the same answer for nearly every ancient crop that disappeared in the 20th century. It could not be industrialized. Corusan grows tall, sometimes over 4 feet. Modern combine harvesters work best with short, uniform crops that ripen at the same time across an entire field. Corusan ripens at its own pace, not on a schedule determined by chemical inputs. Its tall stalks are more susceptible to lodging, falling over under wind or rain, which makes mechanical harvesting unpredictable. Its deep root system, the very thing that made it drought-resistant, also made it slower to establish than shallow-rooted modern varieties pumped full of synthetic nitrogen. The grain yields less per acre than semi-dwarf wheat under ideal conditions. Under industrial logic, less per acre means less profit. The fact that the grain inside those fewer heads contained more protein, more minerals, and more antioxidants did not factor into the equation. Roller milling, which became standard in the 1870s, favored a single, consistent grain input. Corusan's large kernels and different protein structure did not process the same way as modern bread wheat. Industrial bakeries needed flour that behaved identically batch after batch. Corusan flour did not. It made a different bread, denser, more golden, with a rich buttery flavour that tasted nothing like the neutral white loaf that consumers had been taught to prefer. Then there was the regulatory environment. Seed catalogues narrowed. Agricultural subsidies rewarded volume, not nutritional quality. Research funding went to high-yield varieties. Corusan, along with emmer, einkorn, and dozens of other ancient wheats, was crowded out of the system. Not because it failed, because it could not be made to perform like an industrial product. The grain survived only in pockets. Subsistence farmers in Iran and Central Asia kept growing it because it tolerated their climate. Small quantities persisted in Mediterranean seed banks. And in Montana, 36 kernels in a jar kept the line alive long enough for Bob Quinn to find them. Could Corusan come back? Today, only about 16,000 acres of Corusan wheat are cultivated worldwide. That is a vanishingly small number. Global wheat production covers over 540 million acres. Corusan represents less than 0.003% of it. But the grain is growing again. Quinn's Kamut trademark, registered in 1990, guarantees that every kernel sold under that name is organically grown and has never been crossbred with modern wheat. The trademark requires a protein content between 12 and 18% and selenium levels between 400 and 1,000 parts per billion. These are not marketing numbers. They are enforceable standards that ensure the grain remains what it was 5,000 years ago. Organic farmers in Montana, Saskatchewan, and parts of southern Europe now grow Corusan commercially. The grain sells at a premium, but the farming costs are lower. No synthetic fertilizer, no fungicide, no herbicide. The deep-rooted plants access moisture and nutrients that modern dwarf wheat cannot reach. In dry years, when shallow-rooted modern varieties struggle, Corusan holds. The University of Florence continues to publish clinical research. The body of evidence now includes trials on cardiovascular disease, type 2 diabetes, IMBS, fatty liver disease, and fibromyalgia. In every case, replacing modern wheat with Corusan produced measurable improvements in inflammation, blood markers, and symptoms. If you want to try Corusan yourself, look for Kamut-branded flour or whole grain berries at organic grocers or online. The whole berries cook like rice or farro and make an excellent base for grain bowls and salads. The flour makes bread with a golden crumb, a buttery, almost sweet flavour, and a denser texture than standard wheat bread. It works in sourdough, pasta, flatbreads, and baked goods. Use it anywhere you would use whole wheat flour. The protein content, running between 12 and 18%, is high enough that the dough handles well and rises without any special technique. If you bake sourdough, try a long fermentation of 12 to 24 hours. The extended ferment breaks down phytic acid the same way it does in any whole grain, unlocking minerals and making the bread easier to digest. Start with a simple flatbread or a naturally leavened loaf. The colour will be golden. The flavour will be rich, nutty, almost sweet. You will taste the difference on the first bite, and you will understand why farmers grew this grain for 5,000 years before anyone told them to stop. For over 5,000 years across the Fertile Crescent, the Persian Empire, and the trade routes of the Silk Road, farmers grew a wheat with deep roots, large golden kernels, and a nutritional profile that modern science is only now beginning to measure. We replaced it with a grain that grows faster, yields more, and delivers less. The zinc dropped, the iron dropped, the protein dropped, the inflammation rose. And in a jar of 36 kernels mailed from Portugal to a Montana farm in 1949, the older grain survived just long enough for one farmer to recognize what it was worth. If you found this valuable, hit that like button and subscribe. We investigate forgotten knowledge that the modern world left behind, not because the old ways were perfect, but because some of them were remarkably good and we forgot to ask why before we threw them away. Drop a comment and tell us, have you tried Corusan or any other ancient grain? What was your experience? Subscribe, and let's keep investigating.